This is 2008 FRQ number 5, still in the non-calculator portion. Oh, this is one of my favorite slope fields. On the axes provided, sketch a slope field for the given differential equation at the 9 points indicated. So they only want 9 points, 1, 2, 3, 4, 5, 6, 7, 8, 9. They don't want any of these, all right? So use the axes provided here. Okay, so why do they not want these? Because that's when x equals 0, so they'll be undefined, so they don't want them. That's great. All right, let's take a look at when would I get 0. I always look for the 0 ones. When y equals 1, when y equals 1, you get 1 minus 1 equals 0, and 0 divided by anything is still 0. So y equals 1 is here, here, and here. So those are all my 0 slopes. Nice and easy, okay? All right, so now I can do when y equals 2. Well, when y equals 2, let's see, this first point, let's start here, negative 1, 2. At negative 1, 2, I would get 2 minus 1, that's 1, over 1 squared is 1. So that's a nice 45-degree 1. Perfect. At 1, 2, I get 2 minus 1 is 1. 1 squared is 1. That's still a perfect 45-degree 1. Oops, these should look very much alike. All right. And then at 2, 2, I get 2 minus 1 is 1. Over 2 squared is 4, 1/4. So it's a lot flatter than before. Okay. All right. At negative 1, 0. So negative 1, 0. I get 0 minus 1 is negative 1. 1 squared is 1, so negative 1. So perfect 45-degree. All right. At 1, 0, I get 0 minus 1 is negative 1. 1 squared is still perfect 45-degree. Okay. Last one, at 2, 0, I get 0 minus 1 is negative 1 over 4, so negative 1/4. So a lot flatter, but definitely in the negatives. All right, so this is what the slope field will look like. Okay, part A is nice and easy. Part B says find a particular solution to differential equation with the initial condition f of 2 equals 0. So this is where you do the separation of variables. All right, so let's start with part B. dy over dx equals y minus 1 over x squared, and I know f of 2 equals 0. Okay, I need to slide this up so you can see more of what I'm doing. Okay, so what do I do? Do I cross multiply? I can. Let's see. I can multiply the dx over, and I can divide this to the other side, right? So it becomes dy over y minus 1 equals 1 over x squared dx. Okay, so again, watch our algebra to see where all the variables go and make sure they're going in the right places. So this one is y to the negative 1 power. You have a single power y in the denominator. This is going to turn out to be my natural log. So I get natural log of y minus 1. Remember your absolute values. The derivative of y is 1, so I don't need to worry about taking out a reciprocal of that number, right? This is x to negative 2, so we can use power rule. You add 1 to the exponent, so x to negative 1 over negative 1 plus c, right? So I'm going to clean this up just a little bit before I plug in my initial value. Natural log of y minus 1 equals negative 1 over x plus c. Now, the minute I put the plus c down, I want to plug in 2 for x, 0 for y, right? So natural log of 0 minus 1 equals negative 1 over 2 plus c. So natural log of absolute value negative 1 is 1 equals negative 1/2 plus c. Natural log 1 is 0. Negative 1/2 plus c. c equals 1/2. All right. So it's very crucial that you separate the variables, because in most of the rubrics that I've seen, or actually all the rubrics I've seen, that's the first step they look for. If you do not separate the variables correctly and then take the antiderivative, you lose basically all the points for this section of the FRQ. Okay. All right. Now that you have this, put it back into the equation. So natural log of y minus 1 equals negative 1 over x plus 1/2. All right. So we really want to get y by itself, because that's how you solve for equations. So e to the power, so absolute value of y minus 1 equals e to the negative 1 over x plus 1/2. All right. So now, what does that mean? It means that I have 2 possible answers because you have the absolute value. If you recall back in Algebra 2, the absolute value equals something absolute value takes a positive and a negative argument. So that means whatever is on the right-hand side could be positive or it could be negative. So that allows us to split it into two separate equations. Y minus 1 equals e to negative 1 over x plus 1 over 2. Or y minus 1 equals negative e to negative 1 over x plus 1 over 2. Right? So which one is my answer? Well, that's when you use the initial condition again to see what you will get. Which one of these will actually get you 0 when you plug in the 2? So I'm going to plug in the 2. The y minus 1 equals e to the negative 1/2 plus 1/2. Y minus 1 equals e to the 0. Y minus 1 equals 1. Y equals 2. Right? So, nope, that doesn't give me 0. I want 0. How about this one? Y minus 1 equals negative e to negative 1 over 2 plus 1/2. Y minus 1 equals negative e. Negative 1/2 plus 1/2 is 0. Negative e to the 0. Y minus 1 equals negative 1. Add 1 over. Y equals 0. Okay, so this is my actual answer, which means my equation is going to be y minus 1 equals negative e to the negative 1 over x plus 1/2. Now, it does state, if I believe, by the particular equation, there is one little catch. See how these are two separate equations, right? And if you take a look, it is actually telling that the slope field exists on one side or the other, because there is that imaginary, well, there's that line of undefined slope in the middle, right? So if my initial value is at 2, 0, that means my graph is on the right-hand side. So that means my x values has to be all on the right-hand side. So that's just a little catch. If you don't remember that, I don't think you're going to be docked too many points. In fact, maybe 1 point at the most. So if you don't remember, that's really not a big deal. Okay? All right. Part C, for the particular solution that we found in part B. So for my equation, find a limit as x approaches infinity. Okay, so this is back to our limit problem. So limit as x approaches infinity of my function. Oh, I forgot to add 1 over. Sorry. Let me back this up. I forgot to make y by itself. So it's really y equals 1 minus e to negative 1 over x plus 1/2. X is greater than 0. Yeah, just move the 1 over. Okay, so that allows me to take the limit of 1 minus e to negative 1 over x plus 1/2. Right? So let's plug in the infinity. That's how we take, that's how we find limits in the first place. First thing you always try, plug it in, see if you get an answer. So you get 1 minus e to negative 1 over infinity plus 1 over 2. Now, 1 over infinity, 1 over a really, really, really huge number, it's really 0. So that's really 0. So it's really 1 minus e to the 1/2. So 1 minus root e. That's the answer. Okay, that's it for number 5.